Hi, Satish. Can you hear me, Satish?
Yeah. Hi, Papa. So we are live now.
Okay.
So we will be starting at 7 o'clock.
Okay. So how many are there already?
5 people, Papa.
Oh. Sound and all is okay, right?
Yeah, fine.
Okay.
So, good evening, friends. Welcome to IoT Users Club, and we have our topic. And our topic for today is real-time applications of IoT. So, we have our speaker Bappaditya, so who is from Mumbai, and he is a founder of WiseThingz, and he is a product manager, some entrepreneur, and he has designed a beautiful board to make IoT easy. That is Wishtree. So, we can see his board at the end of this session. And we have Papa is going to explain real-time applications which he has implemented in his uh, path of IoT path. So he will be sharing his real-time experience, challenges, and such that it will be useful for us how IoT can be deployed and what are the challenges which we face, which we can overcome with the experience of Papa. Papa, over to you, Papa.
Yeah, thank you, Satish. Thank you for introducing me, and thank you very much for hosting this on behalf. And so I welcome all the viewers for joining us today. And this will be, I hope I will be able to justify your time here. And also the orientation is towards more practical. We won't like talk much about IoT, but we'll look at IoT, how it's happening on the ground. Okay, so because why we are doing this webinar is like earlier also I did some webinar and some few people missed. So one reason is that so that they can attend it, and we will record it so that it is available afterwards also. And the next part is also we hear a lot about IoT, but from a very high level. So how a on ground IoT solutions looks like, and what are the real life implementation and the problems when you implement it. So we'll discuss about those. Okay, so let me go into and share my screen, and we start with this PPT, but PPT is only like a placeholder. So this is not this is only like for me, so that you can understand, so that I don't lose the track. Otherwise, mainly it is photos and videos and explanation of what is actually done. Okay, so with this, so I think my screen is shared with you, right? Right, Satish, you can see, right?
Yes, Papa.
Okay, so let us get inside it. Let me hide this. Okay, so the topic today is real life IoT applications, and we'll talk about maker way because we are all makers here. Maybe someone is very experienced, someone is learning. I still believe I am also learning. So it is the maker way, and we'll see how things are working on ground. Okay, so my name is Bappaditya. I'm a mechanical engineer from Jadavpur University in Kolkata, and a PGDM. MBA from XLRI. Okay, so let me get inside. So this is the introduction part. So I won't just read about PPT. Very soon we'll get into photos and videos. Okay. So what we'll do today is, I mean, you and me, we'll look at the changing business landscape and how IoT is helping. So now we listen a lot about digital transformation, and we hear them from like consultants from so ENY, Boston Consulting Group, and all PwC, and we don't understand what he's talking about. He always says about AI, ML, IoT, but don't show us a use case. It gives us some use case, but we don't know how to do. So we'll see how those things are practically done, how IoT is helping in digital transformation, and we'll review some ground projects, and at the end we'll take some question and answer. And because the time is very limited, it's better to write down your question in chat box, and we'll take it up in the end. So this is a 1 hour session, so we'll keep it try to keep it 1 hour. Let us see. Okay, so Satish, how many is there now?
Yeah, there are 14 people, Papa.
Okay, so let's begin. So let me first tell you. So before we go, so these are the contents. We'll see a few projects like this. So initially, I'll start with this Vortex IoT RCM. RCM is remote condition monitoring. So now we have heard a lot about condition monitoring of machines, automation of maintenance, and all those. So now let us see a company from UK called Vortex IoT, how they are doing it on rail lines. Okay, so now I'll share a web page with you. So initially we have these web pages, but later we'll be looking more into our real life use case. So this is a AI, and they deployed AI and some for camera vision, okay, computer vision, Let us see how it works. Okay, let us see the video, not just explain it. Okay, now I'm going into it. So this is their camera, and this is the edge gateway. Okay, so this is enough. So there is the camera and this is the edge gateway. This is where what is deployed near the rail lines for condition monitoring of the rail lines and how it helps. Now let us have a look at this video. Okay, it will say us how it helps. So I believe this much is enough. So this is how UK railway system. It is all private player in UK. So they deployed their things, this surveillance thing. So to save tape and any tree fallen. So this is a computer vision based AI based solution. So these are the rich countries who can deploy such kind of thing in their country. So probably India will also do it at some point of time down the line. So but is it that, so this is kind of the change that is coming into industry. So this is kind of condition monitoring that we hear about. So is it that only rich countries are doing IoT? It is not such. So now we have seen one project which is done in a rich country by others. So now let us have a look where we are also involved. Okay, so this is one company. This is from Kenya. .ke stands for Kenya. So this company from Kenya and the same company operates in Tanzania, Nigeria also. Okay, so Satish, I am clear, right? Screen and sound.
Yeah, yes, Bappa, perfect.
Okay, so this company is from Kenya. They also work in Tanzania and Nigeria. So their people are very poor, so they cannot even afford a whole gas cylinder. Okay, it is very costly for them. So they came up with this smart gas cylinder knob. Okay, so what this do? So I would like you to just read this part, this highlighted part. The smart meter allows you to buy as little as 1 ksh. It is a unit of gas using M-Pesa. M-Pesa is a mobile payment service. You can pay just for the gas you need today. So this is what they are doing. So because the business is not possible, if you tell people to buy the whole gas cylinder, they can buy a day's gas. So they can pay for 50 rupees and use that much of gas. So how this thing work? We are also involved in this project. So the scope break is like this. So there is a app which is called PayCook, which we developed. So I'll show you a few slides about PayCook interface. So I have taken permission from Mr. IKOB. He's the contact person there. So this is, they have only simple 5-6 screens. So here they can cylinder. So once the recharge is done, okay, this is through cloud. There is a SIM card there inside 2G. Okay, so the data is transferred to this module. So it will, if 50 rupees is filled up through M-Pesa, this knob will deliver 50 rupees of gas, and then it will auto shut and also tell the app that the balance is finished. Okay, so the scope boundary is like this black line. I think you can see my mouse pointer. So this hardware part is done by others because it is in another country, and also it needs a lot of certification and all to work on LPG. So cloud and pay and this app part we are doing. So we have the APIs that they expose to us, and we are using those. So this is one project. So it is not that only rich countries are doing IoT. Everyone is doing IoT in their way. So this is how new business models are being possible only because of IoT. If this thing was not there, network was not there, this would not have been possible. Okay, so these are the two projects that we have talked about. So now what we'll do now, so this both the projects are like from other part of the world. So now let us see where we are involved directly. So let us have a look at those projects. Okay, so now I'm going into their inventory management. Okay, so let me come out of here, and let me go again into this photos and videos, because it is very practically oriented. I told you at the beginning. So now you see, inventory means what we, it is a smart supply chain solution. So what do I mean by inventory? So I show these photos because sometimes people misunderstand. So this is the kind of inventories I'm talking about. This is the kind of stocks, okay, I'm talking about. Okay, you can see here, this is from IRCTC railway godown. This rice, okay, there are various type of rice, not only one type, there are various types. This is a retail store. Okay, so this is the kind of inventory that we are talking about. So the trouble is, you can see here, there are too many items. They are called SKUs, stock keeping units. So a Britannia 200 gram biscuit packet is a SKU, and same biscuit 500 gram packet is another SKU. So what they need to know in real, that which stock, what stock is there, how much is there, and where it is kept. So in such a warehouse, it is really difficult to track, and most of the cases these are like maintained in ERP. So in ERP means someone has manually entered the data, like two carton boxes of Britannia entered, one carton box exited. So this is manually entered. Sometimes it is not entered as it happens. Sometimes it is like just written down on a notepad, on a note khata, and then it is updated in the system, say after at the end of the day for everything. So this is the kind of situation there, and there are a lot of chance of errors. So what we have come up with, so we are offering a IoT solution here. So let me show you a video. This is an explainer video. This will help to you to understand how things are working here. Okay, and then I will show you a PPT, and there are some machine learning also involved here. I will explain those things. Okay, so have a look at this video.
Hello, welcome to WiseThingz. Are you lost in your inventory tracking? Too many items to keep updated on? Gotta do a lot of data entry to maintain the store list updated, and still not sure that what is showing in the list is actually there in the store? Or forgetting some items while placing an order is an everyday problem. Worry not, our connected inventory solution can solve all these problems for you and can do a lot more. Our solution places a Wi-Fi connected smart pallet under your inventory items. It takes the item weight at a regular interval and sends the information to your desktop or mobile phone over internet in near real time. So you can keep an eye on all the storage items sitting in your office or from anywhere in your mobile. You need not do any data entry whatsoever. Information can be collected from a moving vehicle as well. Not only that, our device can send you an SMS or an alert if some item is very low. It can create an order list for you or send the order directly to the vendor. It can do daily reconciliation against sales or material issue to detect any theft. It can also generate daily, monthly, and yearly consumption and receipt report. For a visionary customer, it can do a lot more, like forecasting, order optimization, predictive ordering, and can save a lot of operational cost and headache. So save on your time and manpower cost in store management and concentrate peacefully on what matters more. To know more and arrange a live demo, please call us at 75066 50464 or mail us at sales@wisethings.com.
So I think this much is enough. So this is how this thing worked. I think you could guess how it is working. Okay, so without explaining much, what I will do, I will show you another video, so where you can see this happen in action. Okay, and it is not only about weight. You can also take count and level. So like something is very big, you cannot put a smart pallet, you cannot lift it up and put a smart pallet below. Okay, so in that case you can also measure level. So I show you another video here, which is because we do not have we could not go in customer place to do the video. We did it at our office. So you have a look at this video and you will understand how these things work and how the portal looks like, and then I will explain. Okay. So here you could see how this thing work. So it actually automatically take the data from your smart pallet or smart level gauge or smart counter, say every 10 minutes, and send the data to a portal. So now let me get into this PPT here. So here is what happens because of it. So as you could see, there is a simple dashboard. So you can see this dashboard. You need not see all your item one by one. You can just have a snapshot view. So you can set a threshold for every item. If rice is below 200 kg, you want to order. Okay, so in that case you can set a threshold at 200 kg. So when something is below threshold, that come here under this. So this is below threshold, and you can just click here show record, and it will show you the record. What are the item, which one is the item out of 6 which is below threshold. So you can just look into that, or you can and otherwise you can have all the items. You can do show record and you can see all the items, and the dashboard is also it has a itemized dashboard and a snapshot dashboard. So what are the advantages of using this? So as you can see, get rid of hectic and error prone manual data entry. So first thing is that. So let me open another PPT, which is, so this is how IoT is helping to make things easier and productive. So this has got few low hanging fruits. So get rid of hectic and error prone manual data entry to track inventory. Use your time and energy productive way. Then get the whole inventory status at your fingertip and wherever you are. Also one click report for daily, monthly consumption. So that is a low hanging fruit. There are a few more low hanging fruits, which is low item alert. You get a low item alert and you can create a order list automatically. Okay, reconcile and detect inventory anomalies in real time, and you can do it for all items every day. Okay, so that is one advantage. Then you have some long-term objectives here also. Free of working capital. So I will show you how this setting dynamic reorder point and safety stock help you reduce your working capital. Okay, and reduce sourcing cost also. So, and another long-term objective is they exactly know the risk reward trade-off between inventory. So it is kind of mathematics. When you have IoT, it is mathematics. You need not work on your gut feelings anymore. So because the data that IoT produces is the best data possible, because it is already formatted and not a manual entry. So sometime it is 2 decimal points, 3 decimal points. So those kind of things don't happen. It is a uniform thing. Okay. So now let me tell you about some analytical use case. So let us look at this. So is it interesting, and also like I am clear on sound and visibility?
Yeah, yes, Papa. You are perfect.
Okay. Okay. Then this if you see for any item, so this graph is for say any one item, say it is ice cream. Okay. So what happens normally when like think a shop like DMart. Okay, a DMart or any outlet retail shop, big bazaar. Okay, so the thing is like this: they have some inventory at some point of time. This is the level, and as the day passes, they sell it, so the inventory level goes down, and at some point they place the order. Okay, then after they place the order, it takes like kind of 3 days, say 3 days to replenish, because they will place order, the item will come, the truck will come, and then they need to replenish. Okay, so now what happens, in 3 days this is further reduced, and once the item arrives, they fill it up, so the inventory level again goes up. So why this safety stock level? So the safety stock level is because of two reasons. One is your during these 3 days your consumption can go higher. Okay, you can maybe consuming at higher rate, so the slope is more steep and you go below safety stock. And another is the refill may happen not in 3 days every time. Maybe there are rain or some other reason, and it happens like it took 6 days to replenish. So that is why the safety stock is kept, so that you don't go below empty, even if there is, because there is some uncertainty to address that uncertainty, they keep some safety stock. But this is almost never used, and this is just your working capital which is stuck. And why it is stuck? Because you don't want to lose business. You don't want to say customer, no, now I don't have, I am out of stock. That is why you keep this stock. This is kind of a like, if you say no, then maybe the customer go to another shop and then he stop visiting your shop. So that is why this safety stock is always kept. So now say this was happening like this. Now in the summer, what happens? The ice cream consumption gone higher. Okay, so the slope is very steep. Now what happens? It comes to the reorder point and you place the order. Okay, so you have made no mistake, you place the order, but the problem is the consumption rate is very high, that you didn't notice, because it is not possible for a man to notice every item that whose consumption rate is getting higher, whose is getting lower. That is not possible for a man. He will only order when it is below reorder point. So what happens, within 3 days it is delivered, but still you go empty and you cannot deliver to some of the customers. So that is one thing. If you deploy IoT and deploy some machine learning in the device, it can detect the slope also, the consumption rate, and it can warn you that you shouldn't reorder at this point because the consumption rate is higher. So you see, but this graph is for manual operation. So you see, the next time what you do, because you know now the consumption rate is higher, what you do, you set the reorder point higher. So now this time it is okay, you don't go below empty. But then the summer is gone and it is say rainy season again, and the consumption rate is slower now, but you didn't notice that. So what happens, you order at this higher reorder point and the items arrive, and you are now overstocked probably. So because it is ice cream, it needs refrigeration, it needs space. Okay, your warehouse may be rented, so it needs a higher rent, and maybe some of the items is also go obsolete, means expired date. So those kind of things a IoT device can automatically control, so that is where we say automatic. So this reorder point, safety stock, all are like dependent on some historic value always. So they are doing the business for last 10 years and they know where the reorder point and safety stock point should be, but they don't know it in real time. But now we have IoT, so what we can do, we can know it in real time. So that is one advantage of IoT. Now I will so if you see in the order window, what they have, those threshold, they can have a fixed threshold or dynamic threshold. This threshold, they can decide. If it is dynamic, then the machine decide when it is to be ordered, but it still don't place an order without your confirmation. So you can still review it and approve or unapprove. And quantity can be prefixed and manual and EOQ. So what this part is, now I will explain. Prefixed is, you said whenever item is low, order this much amount. Okay. And manual is, you will manually enter whatever you want. You have no prefixed amount. And EOQ is automatic economic order quantity. So what is that? I want to explain a bit. So that is, say this is a noodles factory, okay, and these are the requirement of eggs. So, and this is the forecast. So and these are in thousands of eggs, okay. So in month 1, month 2, so like 12th month, you have this forecast. And how you got this forecast? Because from last year you have seen what is sold, how much you need it, and you will also look at that trend, and you will do a time series forecast. You will get this forecast. Okay. So now the thing is, you can order these things like every month. So every month there are two kind of cost mainly involved. One is order cost. So you need to order, like you make a phone call, you book a truck. There is some transaction happening and they load the truck and they come here. So that is one kind of the order cost. So every time you order, you incur this cost. Another is inventory carrying cost. Inventory carrying cost means you have to keep them somewhere. You may need to keep them refrigerated. You may need some guard to guard the warehouse. So electricity bills, light, fans. So these are the things that are inventory cost. So what you can do when you have this forecast, you can either buy every month. So you cost like 12 times order cost, but your inventory remains low because every month you consume your things. Or if you want to reduce your order cost, so you can order this whole 12 month at one go. Okay, your order cost is, but you will have a huge inventory carrying cost because there's a lot of quantity, they might get expired and all those. So there the economic also, what is the best mix that you can order? So there this economic order quantity concept comes in. So this can be done at the server side. So like EOQ methodology says, like you order 166 at a time, 166,000, right? Like, so when you consume 10, you are left with 156, again consume 10, left with 146, like that. So the cost is 4865. Okay. And there is another methodology that says let's take two periods demand together. Okay, by two months requirement together. So you club 2 months requirement and buy together. So that gives you a cost of this. Okay, so I will share the PPT. You can verify these things. So you see, you can just by doing this, you can save so much of cost. Okay, and this is not for only one item. You can do for a lot of item, and this is not done isolately like this. What I explain here, it is done in aggregate. Okay, aggregate means this warehouse not only hold egg, this warehouse also hold like atta, maida, those things also. So you need to do a optimization considering all this, your warehouse size, your the amount you can keep, the amount you can consume, and then many other things. So you take together and give a best optimized solution. So this is so with this this is the inventory solution. So with this is done. So now let us now, so this is a smart supply chain kind of thing, smart inventory solution. So smart supply chain is something everybody is behind. Okay, so this is like ripe for disruption. Let me see what is the time. Okay, 1929. Okay, so this is ripe for disruption, but there are other fields like agri, which is much out of like technical mambo jumbo, but it is, even that is also like affected by digital. Okay, let me drink some water. So what is happening there? Let me now show you a Beehive project, Beehive keeping project. So maybe everybody is not familiar with Beehive keeping. So this is like farming honey, like farming honey. So I'll show you a few photos so that you will understand. So now let me go back here. So Beehive. So first I'll show you some photos so that you can have a feeling of how it happens. So this is a Beehive agriculture field. Okay, so the Beehive farming is done here. So these boxes are called Beehive boxes. So the farmers keep like 30-40 beehive boxes together near a flower plantation. So this is one location. So this is probably the same location from other angle. So it is this place is called Harali. It is some 8-hour drive from Pune. Okay, so we are fortunate to get this project, uh, and so these are the boxes. You can see inside the boxes there are some racks. Okay, inside these racks, this is the plan view of a box. Inside these racks, the honey, there are bees, and these honeybees create honey here. Okay, so once this box is filled up, they need to extract the honey and sell it. Okay, so the trouble is they are only 2 or 3 personnel. Okay, and these boxes are kept wherever there is a flower plantation, like here. Then after say 30 boxes here, then after 2 to 3 kilometer or 4 kilometer there is another flower plantation. So some boxes there, then some boxes another 3 kilometer away, like that. And they have one bike. So when the box is filled, they need to know and which box is filled. The trouble is you need to go to each site and lift up the boxes and then check if it is filled up. So they came up. So we came up with this project. So this is a box that we had at our place. Then we did some load cell attachment, and we put some battery driven device, and also we did temperature and humidity the detection for this, because the honeybees are very disciplined. We never knew that before we did the project. So look at this video. So if it is very hot, what they do, they don't go and collect honey. They sit there and fan their hives, because it may get melt if it is hot. So look at this video. So they are actually a very disciplined lot, and so they also this bees should also like their queen. So in a box there is one queen and all other are worker bees. So worker bees should love their queen and all those, then the honey production is very good. So there is some analytics also involved. I will come to that later. So let me now show you one PPT, or probably let me see. So India, like honey is currently very sought after thing. India ranks 7th. Okay, in European countries, honey consumption is really high because they know the benefits. So I will not tell you a lot about this PPT. Let us directly go to how we did it. Okay. So there are different kind of architectures available. So you when you go to site, you see sites like this where there is no network connectivity. Okay. So there, how it is done, you can read out the steps. So there is a mesh cluster of honeybee boxes. So all these, because there is no network, so they are connected like through Wi-Fi, and they can talk up to like 30-40 feet. So they occasionally, like once every 4 hours, they send their weight, temperature, and humidity to a master installed at site. Okay, temperature, humidity collected from boxes and sent to the master each hour, and then master saves the record in its memory, because there is no network, so it cannot send. And user can take a smartphone to site and download the data from master. So once he goes to the site, he can just download the data, and he need not lift and hold all the boxes. He can just in the list in his mobile phone, he can see how which box is filled up. Okay. Then there is some site where there are GSM network available. So what is done then? There is a GSM gateway. This gateway needs power. Okay, everything is these boxes are powered by battery, and the design is such that the battery should work longer. Okay, we did a lot of optimization to achieve that. And then this gateway thing, this has to be powered, and this send the data to the server. So you even need not go to the site, and you can know from the server in the dashboard that which box at which site is filled up. So you can just go there and need not roam around everywhere and lift all the boxes. Okay. And the third one is site with temperature, temporary or permanent Wi-Fi or MiFi hotspot. So other thing you can do, you can take a MiFi hotspot, or your phone, you can make your phone a hotspot and say go to site and make your phone hotspot and send the data to cloud platform. So this is temperature and humidity weight collected from boxes, sent to master. Master, if connectivity available, send the data to cloud, else save it. User can bring a smartphone to site, download from master, or whenever a hotspot is found, data is transferred to the cloud. So this is how these things works. Okay. So this is about Beehive, and it is not that we are doing something very advanced on Beehive, because I want to show you this website. You can see people are researching a lot in the Western world about beehives. Okay, so I would like to run this video, not but just not the whole video length. So if you see, they are doing a lot of things, like they are researching a lot on beehives. Okay, they are deploying satellite imaging and everything. Okay, how many bees entering into bee counter, so you can deploy this thing. So you can also count how many entering and how many exiting. And then there are hornets that kills bees. So this is a photo of a hornet. So hornet wing flap make a different kind of sound. So if you have that kind of sound detector, you can also catch a hornet. If a hornet is there, it will kill at least 100 to 120 bees. Okay, and hornet also attack in a swarm, not so they are doing all these things, satellite mapping and all. So if we are not deploying technology on beehive, honey collection and honey cultivation, then probably now we are in 7th, and in very soon we'll be maybe in 10th, 15th, like happened to our hockey team. When there was astroturf, we did not deploy astroturf in our country, and now our hockey team is, once it used to be a champion, and it is now fighting, right? So that might happen. So this is one. So this is about agriculture. So it is like for almost 37 minutes into the thing. So now let me see what I have. So now I'll show you just so two big things: inventory management and beehive keeping we are done. Okay. So what now I'll show you like a Weighbridge. So now these are like big things, like agriculture and like smart supply chain. So these are like industries, and very biggies are doing it. But is it that only in bigger places, bigger companies, and are doing it? It is, IoT is even happening at very grassroots level. So I'll show you a few video. So this is a Weighbridge video. Okay, so I'll show you the video is self-explanatory. It is a weighing bridge. So you know, in Weighbridge there is a truck or something else, and then the weight is conveyed to a machine, a computer. Okay, and the entry is made. But there are wires so going through. So when now we have IoT, why do we need those wires? Because those are trip hazards for the people. Like a truck is there and they are carrying some sacks on their head, like 50 kg, 70 kg cement sacks. Okay. So what is the trouble is they don't want this wire there, because people trip sometimes, or sometimes the wire is torn. So they wanted like this. So how can we remotely send the data to their computer? So this is what is done there. I will show you a video. Okay, this is done through LoRa. So it works up to almost 700 meter to 1 kilometer, 1 kilometer in the open, and 700 meter when there are walls inside. So please have a look at the video.
And it's remote display running on LoRa protocol already, because tomorrow is the delivery. So both are running on battery, and whenever there is something on the weighing device, it replicates there on the remote display. So, and this works up to 1 kilometer in the open area and up to 200 to 300 meters with the obstruction in between. So say we want to weigh this battery, so keep it here. It is 400 grams, and the same is showing here, but we can say no, it is not 400, but it's 300. So you can calibrate it like this: 1, 2, 3. So from now onwards, it is 300 grams. Also, you can go to piece mode. So say this 300 grams correspond to 3 pieces. So you can set it up 3 pieces. So this is 3 pieces. When there's nothing, 0, keep it like 3 pieces. You can go back to weight mode and tear it here with 300 grams on top of it. So when you remove it, it shows minus 300. So that's it. Thank you very much. Bye. So our digital weighing scale.
So here there is the remote display. So this runs on a bigger battery. So this is not actually in a battery. This is powered and near the Weighbridge, and this is near the operator who is sitting on a laptop or desktop. So he can see it there, like say so he can sit like further away, like 100 meter, 50 meters, or 70 meters, 100 meter, and he can take the data from there. So you can see the data is replicating, right?
Because tomorrow twice it replicates there on the remote.
So this is something, and now because we are all makers, I also have kept for you a maker view of the same video, okay? Because we like it this way. So first one is the business view. Now let us have a look at the maker's view, okay? So this is the maker's
Hello
view.
friends, so here is a retrofit IoT project. Here is a digital weight scale. So we'll make this still smart. It will send.
So you can see everything is out here, out of the box.
On the enclosure. And here is the load cell. When something is kept, it records the weight. So, and here is a display, remote display running on battery.
So
currently I'm using power bank.
So this is on power bank.
Something is kept on this. The data is replicated here. And this thing works up to 1 kilometer in the open area, and 200 to 300 meters in the confined area.
So I think you people have liked it. This is the maker's view of the things before it is deployed, very neat and clean at site. This is how it looked like, okay? Just for my confirmation, Shatish, it is all okay now? Like my voice and view, the display?
Yeah, perfect, Bappa. So people are enjoying it. The Beehive box and the inventory management. I think we are going good.
Okay, thank you very much. Because I see and I hear no sound, so that is why I'm thinking like I'm talking to
Yeah, this is only one way, Bappa. But from the comments, from the likes, I'm seeing they are enjoying.
Okay, thank you. So how many is there now?
23, Bappa. 23 are watching our video. Yeah.
Very nice, very nice. So now let us get into another very simple use case, which is a shop floor use case. Okay. So you can see there is a these are the forklifts. Okay, you can see probably this photo. So this is a forklift, and this is a 2-ton forklift. Okay, so 2-ton with 2000 kg. So you should not overload it. So when you overload it, what happened? The bearing like gives way, bearing get damaged. And these are all Chinese items, so you don't get a bearing readily available in India. So the whole thing is like a scrap. Okay, so the workers are told not to like overload it, but they always overload it. So what the owner wanted us to do, like whenever somebody like overloads it, I should get an alert or something. Okay, so now first this is a POC that we have done in floor. So let me show you the POC first, how it works, then I will explain. Okay.
So hi guys, here's a smart forklift. It can sense the weight kept on it and transmit over LoRa. So now there is nothing on the forklift. Now I stand up on it. Okay, I'm 72.8 kg, and there is one display on the forklift itself, and you can see this, the transmitter and receiver are exchanging data. Okay, and this shop floor is like 70 meters long. I can walk along, and we can see how far this works. For open area, LoRa works up to 700-800 meters without problem, and even in obstructed area, it will definitely work for.
So this is just the testing how long I can go. So I did that up to around 700 meter, and then the floor ends. So and then I tested outside, it worked almost up to 1 kilometer. So this is the POC, and then we also did the actual device. Okay. So how it worked? So because this is within a shop floor, you do not and we are using LoRa, you don't need like SIM card or Wi-Fi hotspot, anything. This shop floor is like 700 by 700 meter. Okay. So what is done whenever like whenever there is a overweight, so there is a big display on the floor. So what happens whenever someone is like overweighing it, so it will show on the display. They have 5 of such forklifts. So it will show the name, and there will be a buzzer which will ring very loudly, t t t t. So that is how then the shop floor managers, they are all sit, and they're in around the shop floor, they have their offices. So they will see this forklift number so and so, user so and so overweight is. overweighted it. So this is kind of a shameful situation for that worker also. So then they stopped overweighing it. So by I should have told earlier. So say this is a 2-ton forklift, they need to move 10-ton weight from point A to point B. They should do like in 5 times, 2 plus 2 plus 2 plus 2 plus 2. But what they do, 4 plus 3 plus 3, kind of like that. So now they stop doing that because they know they will be highlighted. So this kind of smaller deployments are also there. Not everyone is doing rocket science. So that is what I want to say also. Like if we talk to ENY, BCG, and TCS, Wipro, Infi, they are all talking very well, at high level. So this is how ground level IoT is working now. So I have shown you a few use cases from some beginning to end. So we have some other things as well if you look at the PPT. But the trouble is I do not have a lot of time. So only maybe 15 minutes left. So I have shown you already this. So now I'll come to the deployment problems. What happens when you deploy? So one is very particularly problematic thing is battery life. So this is very so there are ways like batteries come in milliamp hour, and then you can measure your current, and you can divide milliamp hour by current, and you get the hour, how many hour it will run. But it normally don't work that way, because the batteries are also, they give you a range of milliamp hour, and some batteries give you a minimum milliamp hour. And your device also like don't always follow that similar kind of, like when it is searching for Wi-Fi or searching for GSM network, then the battery consumption is higher. And how you have coded it, and how much design consideration, like there are like components where even when device is sleeping, so sleep mode current is very low for the microcontrollers, we know. But there are other components like a voltage regulator, maybe a 555 chip, maybe 555 IC. So they will anyway they will consume their quiescent current. So a battery life can only be like, when customer asks you how long this device will run, you have to say a day, like time, like 6 months, 3 months. But at the time of giving him, you also know, unless I run it for 6 months, I am not very sure it will work for 6 months. So this is about battery life. And another deployment problem is like system reliability. So to work this IoT thing to work from end to end fully successfully, it should work from sensor up to front end, sensor, device, network, cloud, front end. So you have sensor may fail, it might get some dust, there may be moisture in the air, so the sensor stopped working. Maybe sensor has got some like permanent deformation, some permanent offset. That is first thing. Then you come to device is very hot, the tracks are not good. So this kind of thing, device cannot connect to the network, it is restarting automatically. Okay, this kind of thing. Then comes network. In network, 2G, 3G, then your location, you are using a vehicle tracker and your truck goes inside a trench, so you don't have network. And then you have at the cloud end, there are like queues in, like the packets are coming there in Kafka queue, and then they are going into the database, and then they've queried from there. So every stage there is a reliability. So every stage, if it is 0.9, like 90% reliability, then end to end it is 0.9 into 0.9 into 0.9 into 0.9, like that, it is like very low. Okay, so that is one thing. And in India, the things are like not very reliable, even the network also. So many devices use GSM network, but like our phone call drops, there also have some drops. Okay. And then the other thing is, now all the people, like the customers that come to us, is like really, they are doing like, most are in testing phase, they are not deploying IoT at scale. Nobody is deploying IoT at scale. So what they are doing, they want to test the water, so they want to do something in low volumes. Everyone want to do something in low volumes, they want to do POCs. But to doing something in low volumes, per piece cost is very high. So this is one thing that is stopping the like the customers also. They want to test, but they don't want to spend a lot of money to test, because if you want to test, you have to design like say 3 devices, so you may build PCB for 3 devices, and so this is high cost. Then if you want a like finished PCB and enclosure casing, so you go for molding and all those, or 3D printing. So the costs are becoming very high at low volume. And then the way out is you go to China and to take the ready-made devices, And on ready-made devices, the problem are it is like you do not have whole freedom to modify it, to code it, because you don't know what is happening. So they will give you some APIs, and you are bound to follow those only. So you cannot like say, okay, I will put another MOSFET here, so that will save my some current, so I will lengthen the battery life. So that is not possible with bought out devices like this. So your user says, I need a like quick tear button, like I want to set tear with this. So a quick tear button, you cannot like readily put it on, like you cannot solder it on a existing device that is bought out from China. So that is one thing. And another thing is the last mile problem. Last mile problem is, it is a very practical and physical thing, IoT, which is like trying to make a connect between physical world and virtual world. So virtual world is, you I would say, much more stable, and not stable, but much more like disciplined and like in a pattern. And real physical world is like anything. So this is the last mile problem. So say a DG set fuel monitoring is very sought after solution. If someone can come up with like a foolproof something about saving DG set fuel theft, so they will make a lot of money. But the problem is, when you go and check some DG sets, there are many Powerol from Mahindra, then there are from CG. So and there are like customized also. So if you go and see there, you will see they have kind of drums, though diesel drums, which are very different in shape. Some people even use drums, just those cylindrical drums that we see in shops. Like I used to see them in kerosene shops when I was like children. So they've been using those kind of drums. So it is very difficult to standardize it. And then there are a lot of ways of like stealing diesel. So someone is taking out the drain valve, someone is pouring and mixing with water, someone is siphoning out by sucking it their by their mouth. So there are a lot of ways. So this is the last mile problem. So if you come up with a DG set solution that can detect diesel theft, you cannot expect a standardized behavior within the people who are using. So that is what I call a last mile problem of IoT. Okay. So this is a practical world problem. So now these are IoT product design and all. So we are already 50 minutes done. So I won't explain this anymore, because these are like now we are getting into like IoT design. So I think the makers here would love it, because but I do not have the time to go the how. So this is how the hardware is. Like if you see, the device has got like silicon modules and PCB. So devices are PCB. So I will show you a photo. What are those things? So if you see, this is a PCB, this is a GPS tracker, this is a PCB, okay? And you can see this white part. So this is called a module. This N720 is a probably is a 2G or 3G module, something. Okay, you can search it in net what it is. N720, right? N720. It is a new way wireless product, something. Okay, it is a LT module. Okay, long time evolution module. So this is a module, and then when you open up the module, you see the silicons. Okay, so we are still not making silicons here in India, so we are dependent on other countries about that. So these are the like these are about design considerations. I won't get into those. So this is the platform topology, IoT topology. This is the hardware. This is the network, the middleware, front end, and BI. And I also used to do a live demo if there is time, but it is not here. So now we come to the closer part. Okay, and so this is my coordinates here in the last slide of the presentation. So you can call or mail me, or follow our YouTube channel or Instagram, okay, or Twitter. So now we can take the so we could, I think in the closer, I'm now into the closer. I think I will take the questions now. So could we see how digital driving changes business? Probably we could see. So till date we have heard from a very high level, but now after this presentation, I think I could justify your time, and now we can see how it is really changing the world. Okay, and but this is too much of a new situation every day. What do I do? So that is a big question. Even we are also learning every day, because every day there is something new coming up, some new challenge, some new ways of doing things. So what I would say, like, it is learning. It is learning. So you are always at a learning phase. You never, you won't say, I have now learned 100% of IoT, nothing is left. This will never happen. Okay, and then now let us move to question and answer. So if there is some in the chat window, we'll take those.
Yeah. So Bappa, so IoT is helping a lot. I think you are also helping the IoT world by with your Vistry board. I think you forgot that one to share with the
Okay, okay,
IoT
okay.
users, club users.
Yeah,
Yeah.
sorry. So we have a board for the makers. Thank you for reminding me, Satish.
Yeah.
So we have this board for the makers. So Vistry board is based on. So let me show you a video. So this is the board. This allow you to use any kind of. Okay, let us. So this is the board. This accommodates like ESP12 and ESP32 both. So as you know, ESP12 has Wi-Fi and ESP32 has got BLE, Bluetooth, and Wi-Fi all. So this board accommodates this both the modules. Okay. This is kind of a development board that makers can use to do their POCs or even can deploy if the solution is not very critical. And it also provides you options to attach many other sensors and network connectivities, and and your display and those things. So let me show you this video. With this, I think you will be able to get everything rather than speaking. Let me show you the video. Okay, thank you. So these are the so you can see this in our website also in detail. This board is called Wishtree, and it actually allow you to do Wi-Fi, Bluetooth, BLE, GSM, and LoRa all on a single board. And as you could see, you can attach all the display, memory card, and RTC timer, everything on it. So this is a very good and shoulderless kind of POC. So you can get details in our website also. So this is about the Vistry board. This is for makers, and we have all APIs available, and we have screen circuit schematics ready there in our website. So those kind of helps you will always get from there. So if you see, these are the feature list of Vistry do. So these are all available there. So what are the communications, and the size is also like credit card size board. So you can see the same thing is there in our website also, so you can refer there also. Okay, this is the website. Okay, so thank you Shatish. So now I think we can take the questions if there are some.
Yeah. Thanks, Bappa, for making the IoT reachable to everyone, and also your Vistry board for quick prototyping. People can use that board for quick prototyping and learning IoT. So I have framed some few questions, Bappa. So
Yeah.
let's see. Uh, so there are always challenges, Bappa. So when we implement, so the first thing is it will work in our lab, but when we go to the ground level, it won't work. So in
Yes,
your
yes.
implementations, have you faced any such challenge which you can remember still now?
So you can see in the Beehive thing. Okay, so this is a challenging one. So one of the time we even could not reach site because of heavy rain. So apart from that, actually this thing is like when practically we was using it, so we put some load cells under the box. But the thing is, they need to carry these boxes from one side to another side sometimes. And how do they do it? They put one box on top of another box, and then another box, and load this in a truck, and then go somewhere else. So what happens when you keep one box on top of another on top of another? These load cells are pressed down, and there is some their zero set is removed. So zero setting you need to do again, so when you reach at the new place. So this is one practical problem. Then another problem that happened to us in the Beehive only. like it's the battery life. So we tested it in the at our office, so it was working nice. So it current draw was very low. So as per our calculation it would work for 6 months. Then what happened, within 7 days the battery drained out. So who were deploying it actually was very helpful, and also a technical person himself. So he helped us to then we check the code. The thing is, there is some problem in deep sleep, like we didn't know it much very well. So when we call it for deep sleep in microseconds, and we call for a deep sleep for 1 hour, okay, it actually don't go to sleep. So what happens, after sleeping like 5 to 10 or 15 minutes, it wake up, okay. So we didn't know that, so it wake up and it keep its Wi-Fi open for 45 minutes, then send the data, then again go to sleep for 5 to 10 minutes. So when we tested it continuously at our lab, like we kept it on and started looking at it, then we understood it is not actually sleeping for more than 15 minutes. So then what we had to do, we introduced another configuration parameter, that sleeping multiple. So we instructed that sleeping deep sleep, this is configurable. So deep sleep you can put maximum 15 minutes, and if you want 1 hour of deep sleep, you put a multiple like 4. So when we did that, it worked well. So this is the kind of thing. So only once you deploy it and like it works for 1 hour, 1 year, probably then you see, now I think this is stabilized and we know what we did. The things are like that.
Yeah, good to know, Papa. So this is something. So for electronics, we don't know how it behaves in the real world and in our lab. So I have seen
Yeah.
those things. So, but we have some questions from Sharath. So he is talking about the fixed asset management solutions for larger enterprises. So have you evaluated any use cases for hospitals, something like that, to track the biomedical equipment? I think he is talking about the GPS trackers.
So GPS tracker, we did a GPS tracker. So but now currently we are modifying the design, because the GPS module that we used didn't work very well, like in a bit constrained situation. So when you are very nice under open sky, it gets the GPS signal very fast, it latches very fast. But like even if you are standing in your balcony, it takes time. So after looking at it, we are changing the design a bit. We like did it, we used it, we given it to customers, but then we are now modifying till this modification is done. So probably it will take some time because of the current COVID situation. It is not going through very well. So then we are coming up with a new design of GPS tracking. And
Yeah.
also the other thing is, the technology is changing. So earlier one was in 2G. So the thing is, everyone telling that 2G will phase out, and some of our products also go to Belgium and US. So probably they will phase it out faster than us. So there is some Quectel modules which are which is a bridge module between, it allows you to do many like NB-IoT 2G plus 5G. So it is like proficient already, you may not use it now, you may use it later. So those kind of design considerations we are doing, so probably it will take some time to come up.
Yeah. Any hospital use cases, Papa? So have you done any implementation in hospitals?
So in hospital, there is one thing like, so this I told you about this smart inventory management. So we have this smart plate, right? So the use case is like this. It is a byproduct of that. Uh, People are using it under gas cylinder and even oxygen cylinder in hospitals, and even in water purifiers, because it can track the weight. So what they are doing, so what we are doing actually, like automatic dispensing of water. So whenever the like this jar is empty, this plate know that jar is empty. So what it does, there is a relay switch, so it switch on the purifier, and whenever it is filled up, so it can again sense it has filled up, so it automatically switch off the relay. So that way this is automated. There is a gas, this is a gas cylinder bank behind a big restaurant. So their cylinders don't last more than like 1 2 day per cylinder. So they need to replace, and they have like 15 20 cylinders there. So they use it to know which cylinder is empty. So they need not come out the restaurant and check here. Also in the oxygen section of a hospital, they know which cylinder is already empty or going to be empty. So they can carry only this much cylinder, come down and replace those cylinder, because these plates are numbered. So this data is coming for plate number 1, so go and replace the plate number 1 bala cylinder. So that way they are using it. So this is the byproduct use case, you can
Yeah,
say.
yeah. So
Yeah,
single product, multiple use cases.
yeah.
Yeah, yeah. Thanks, Papa. And one of the user asking how can we rely on the Bluetooth devices in the real field? So how much? What is the distance the messages
Bluetooth,
and
Bluetooth relay is actually, Bluetooth mesh network is very new. Okay, so I never worked on it. So Bluetooth was normally one to one. So Bluetooth mesh is now there, but I have never used it. It is better to go to BLE, because BLE already deploy mesh. And the other thing is, BLE has got some standard templates also. So those are called UUID or something. I didn't work in that very much, but I think using BT mesh is okay. It is there now, but you will not get much help from the community.
okay. So fine, Papa. I have some. So suppose one want to learn IoT. So from your perspective, what are the technologies we should learn?
So I so IoT is very big thing. So let me show you this slide. Okay. So if you so here you can see the IoT has many facets. Okay. So am I sharing my screen or no?
Yeah, you are sharing, Papa.
Okay, so there is device. Okay, these are the hardware. Then the inside devices go the firmware. Then there's a gateway, then cloud, and then front end. So you maybe end to end learning everything is very difficult. So like I know everything a little bit. There are people who are very specialist in each kind of thing. They do the cloud person do the cloud, device person do the device. So if you want to see learn, so this is all the things that you can learn in the hardware only. Okay, so I'll give you the PPT you can distribute. So in the hardware you can learn about device, gateway, OEM machine. Okay, so for microcontrollers you can learn about ARM Cortex Peak or 805. Peak and 8051 is very old now, maybe you need not learn. Then OS you can learn about bootloader, Linux, RTOS, FreeRTOS, many. SOC SOMs, you can learn about these. Single board computers are there, sensors are there. Then in programming, you have to learn C, C++, MicroPython. Coding, there are so many IDEs. There are so many networks to learn, and there are so many communication methods. Okay, so this is only about hardware. Then you can go to middleware like AWS, Azure, Google Cloud, PHP, Python, SQL, and then there is front end. So these are all the things that you can learn. So you need to choose one of the bucket, or maybe end to end. If you want to start end to end, I think, and you are a very novice, never did it, so the best thing is, I think, start with the Arduino. Take a Arduino, start with it, and then go to gradually move to like Raspberry Pi, ARM Cortex like STM32. You can use Nucleo boards. So ARM Cortex is like when you do ARM Cortex and you use some like high-end boards, then probably you can say I have learned a bit of IoT in the device side.
Bappa, yeah, so lot of things to learn, but do you say Arduino is a production ready board? So we can use Arduino in the production, or may I know which microcontroller you have deployed in your solutions?
So Arduino, I don't think. So normally I am doing on ESP8266 and ESP32, and we are using Raspberry Pi also. So Raspberry Pi, not only I am using Raspberry Pi, even if you see this AVNet gateway, even they are using Raspberry Pi, and they have made this industrial product. Okay, so I think it's better to go to some STM32 ARM Cortex thing.
Boards, okay.
So you can see that this will come. So this gateway, AppNet gateway, is an industrial gateway, and this is based on Raspberry Pi. You can see it here. Okay.
Okay.
So
Yeah.
people are using it. So I think like only after you use it, and then you will know.
Yeah. Yeah, and one more question, Bappa. So how is the IoT market and jobs in India? So people say by 2025 you will have 50 billion devices, but still Are we reaching the target, or according to your perspective, what is the IoT market?
So IoT market in India is people what I have seen still testing. Okay, testing the waters. No one is coming up with a big budget and doing it right out. So everyone is telling like do a POC for me, then I will think over it. But the IoT is something like that I believe will be very essential, very important for industry very soon, because it can do a lot of things that humanly not possible. Like you can see in the inventory management. So only thing is we our physical world is very haphazard. So like I told you about DG set. If you go and deploy a DG set solution in Europe, it is much easier because they will not invent a new way of bypassing it.
Right.
But here,
So India,
people
we will invent a lot. So we first check for the loophole, and then we how to break the things. So we are good at breaking the things.
yes, yes. So I have seen in oil tank, like cement mixer and all. So I was part of on that project. So they have tried many ways. Okay. To stop stealing from the petrol tank of the truck, so they like put lock and key on the truck. But there are drain valves. Okay. Then they put a mesh so that you cannot
Put your pipe. Yeah.
put your pipe through
Yeah.
when they cut the mesh. So and you don't know it is cut. So there are many ways doing it. So it is like it will take some time, but yeah, gradually there is no other way. But IoT will come. And in the job world, I think it's a bit difficult. IoT is mainly being done by product companies. Okay.
Yeah.
And other system integrators like TCS, Wipro, Tech Mahindra, they are still in the cloud, and even bigger companies in the cloud. They never like do the hardware. So and in India, hardware is also not built much. So till the time, so hardware will be done by like these product companies only, this AppNet, Advantech, and these companies. So so it will take some time, but it will come anyway.
Yeah. And I think which board you have already addressed this, Papa. So which is the board which we use in
So, so, so,
deployment?
so here the thing is, most of my projects were like POC and initial deployment, small budget. So I had to go with this. But if someone come to me and tell me I want to build 1,000 pieces of something, I will definitely test other boards.
Yeah. And this is something made in India and make in India. This is something Atmanirbhar Bharat. So is the China is only the source of sensors and modules, or do we have other parts of the world where we can get the components?
So other part means if China is aside, then maybe Taiwan and the Western world, that the things come at very costly cost. They are costly. So maybe because the kind of business I do, the customers come with very low budget. Maybe for big companies, this is not a problem. This is a problem for small initiatives only.
Yeah, so we are trying to find the replacement for China. And how 5G will change the IoT connectivity, Bappa, according to you?
5G. In IoT, 5G is not much required, I think. So in IoT, what we transfer is like 10 bytes of data, 20 bytes of data in one packet. So probably 5G will work more like in the like computer vision, like at edge. Okay, so you want to analyze at edge, transfer so much of data to the server and get it analyzed and get it back very fast. Like your computer, your camera saw some object and it is not in your database within the camera, means at edge. So you want to send this whole lot of image to the server and get it done there. Like Alexa is like doing all the analytics at server and throwing back the result. So those things will be very fast. But for IoT, for 10 bytes, 20 bytes, but we don't need 5G. Yeah.
Okay, and the last question, Papa. So, artificial intelligence and ML is the next big things what we are seeing. So, how it will influence, or how IoT can be related with those things?
Yeah. So you see, so for AI and ML, what I have seen. So before you feed AI and ML with data, you need very nice data. Okay, cleansed data, well formatted data, out of 10 row, 1000 rows and 100 columns, all should have same format and everything. There shouldn't be a blank in any cell and those kind of things. So IoT help you provide you this kind of data, and IoT data is not like it is not from a human source, so it is from like a machine source. So it is always a formatted data, and it won't like miss your data. It will give you data always. It's not like oh, tomorrow is the audit, so let us fill up all the folders. Let us fill up everything, all the files and all. So it is not like that. It happens every day. And also IoT needs AI and ML. So IoT is like kind of giving your data which is at the physical location at the edge to your server, but to make some insights, business insight from it, AI and ML is like very much necessary. So as you can see in the inventory solution, if I only tell him like aata itna hai, chawal itna hai, that is something. So it is like some kind of convenience. But if I can like deploy dynamic replenishment point, dynamic safety stock, and I can do economic order quantity and club the and optimize the warehouse uses. Those kind of things will actually create a lot of business value to the owner, and it can be easily done with the data that is provided. So these kind of things, I think, so IoT and AI and ML will go hand in hand, and that is where the business case will be built when we combine them all together.
Yeah, thanks, Papa, for a nice session and for sharing the valuable information which no ground level engineer will share. So the makers view of the devices, IoT devices. So for the people who want visionary board, they can go to the wisethingz.com and he can find Papa's details and they can contact them for the availability of the boards. So for remaining for future sessions, please subscribe to the IoT Users Club channel and we'll be sharing more information like this. Thanks, Papa, for a nice session.
Thank you, Satish. Bye. Thank
Thank
you,
you.
all
Bye.
the viewers. Thanks.